Okay, let's look at this example where we have a voltage supply that is changed from 1 volt to 10 volts at 0 seconds. And we are looking at a resistive voltage divider and a combination of a resistor and a capacitor. And we are interested in finding out what happens to the voltage VA and voltage VB. And the circuit was stabilized for a long time before the triggering event. So if you look at the 0 minus case, we have Vs at 1 volt. So this has been like this for a long time. So the voltage at VA is going to be 9/10 of Vs, because the simple voltage divider, so what we say is that VA is always going to be equal to 9 kilo ohms divided by 1 kilo ohm plus 9 kilo ohms, because the simple voltage divider times the Vs value. So we have 0.9 volts for 0 minus case. For VB at 0 minus, we have a fully charged capacitor. So it will act like an open. And at that point, VB is at the maximum voltage, which is 1 volt in this case. And at 0 plus, the capacitor voltage does not change, because capacitor voltages do not change instantaneously. We have 1 volt at 0 plus. However, the resistors don't have any memory, so VA is going to instantaneously change to 0.9 of the Vs, which is 9 volts in this case. So VA starts out to be 9 times larger than VB at the triggering moment. As time goes to infinity, VA remains at 9 volts because resistors don't have any time response, while the capacitor charges up to full 10 volts. So if you were to look at this table, you can see that initially, before the triggering event, VB was larger, and after the triggering event, VA becomes larger, and after a while, VB becomes larger again. So there is a window in time where VB is smaller than VA. So if we were to graph what we expect these VA and VB to be in time, we expect VA to go, we know that VA is going to go from 0.9 volts to 9 volts. So assume that this is 0.9 volts here, 0.9 volts to 9 volts. This is not being drawn to scale at this point. 9 volts. And VB is going to look like this. It starts with 1 volt. And it is eventually going to reach 10 volts. And we expect this to happen with an RC charge up. So the time constant associated with this behavior, tau, is going to be equal to R times C. We are charging this 1 millifarad capacitor through a 1 kilo ohm resistor. So this RC charge up time is 1 kilo ohms times 1 millifarad. That is equal to 1 second. So we expect approximately 1 second time. This is in the order of 1 second, where VA is larger than VB. VA is going to be larger than VB for about 1 second. You can calculate the exact timing for this.